Now welcome back to Apostle 1 tutorial. Yes, we are still trying to provide some videos for you to make mathematics so simple for you. Now, so follow me closely as I explain mathematics to you, as I make mathematics so simple for you. Now, this particular one, I am going to talk about one particular thing and the calculus or limitation. Yes, it is very, very important. It's very, very important as mathematics is concerned. Now, I am going to talk about one continuous function, continuous or discontinuous function. Continuous. Oh. Now I'm going to explain continuous and discontinuous function. Now at this particular point, you have to open your eyes very well and then you follow me as I explain. Now I'm going to give you the introduction and anything you're supposed to know under continuous and discontinuous function. And then as a subsequent video, I'll be solving more questions to boost your understanding. Mathematics is about understanding. It's all about true and poor. Yes. Follow me closely. Now, when we say a function is continuous, see a function is a function, any function in the form of f of x, in the form of either f of x or y. And a function can be a polynomial function, it can be a rational function, yes. Now, when we say a function is continuous, it means that, now for a simple explanation, when we say a function is continuous, it means that I can draw the curve or that particular function. I can sketch or draw the curve of that particular function without lifting my pen. Look at something. It means I can draw the graph of that particular function without lifting my pen until I am done. Now, this particular thing is continuous. I drew the curve without lifting my pen or my marker. So we classify this one as a continuous what function. Now, let me give you an example of a continuous function. Now, let me give you only one critical example. Example, let's say a car road. You see the road? Now, you see sometimes how smooth the road is. Now, you go to a particular point where there is a pothole on the road. Now, the moment you see a pothole on the road, then it means that the road is no more smooth again. So the pothole over there makes the thing not continuous. It makes the thing what? Discontinuous. Because the pothole is creating a hole. Pothole is it's creating what? A hole on the road. So that one, it is not what? Continuous. You get it? So when we have a smooth road from Accra to Kumasi without any pothole, that particular road is called a continuous function. You get it? That is a simpler understanding I can give you when we are talking about continuous word function. So the curve of that particular function can be drawn without what? Lifting your what? Your marker. The moment you are drawing this one, then you stop here. You stop here before you continue. Now, what is going to happen here? Now, this one has created an indication here that no, there was a breakages at this particular point. So at this particular point, we said the line is no more, or the function or the curve is no more continuous, but rather it is discontinuous at this particular point. It is discontinuous at this particular point. Yes. Now, so that is what we talk about discontinuous. So the moment there is something there that will make the thing not smooth, we call that particular thing or that particular point a discontinuous word point. Yes, a discontinuous word point. Now, so let me give you now when we come to the function itself, don't forget we have polynomial functions and what? Quadratic functions. Yes, linear function, quadratic function, they are all fall under cubic functions, quartic function, they all fall under polynomial what? Functions. Yes. And then we have trigonometry functions, we have hyperbolic functions, we have a whole lot of functions, you get it? So follow me closely as I explain. Now, note this particular thing. A function, now let me give you something small here for you to write. A function is said to be continuous. A function, a function f, let's say we have a function f, is continuous at s is equal to a. Now let's say a function f is continuous at a particular value of x. Don't forget that the function is in terms of x, yes. It's continuous at a particular value of x, that is s is equal to a. Then these conditions, then it must satisfy these conditions. Now, before it can be continuous, it's supposed to be satisfied by these particular conditions. Now, the first condition is that, now condition 1, the f of the function a must be defined. Now, when we say a function is defined, it means that we can what? We can tell the exact value of the function. Now, don't forget that finding f of a is something simple, right? Example, if I have f of x is equal to 2x plus 1, and I'm looking for f of a, it means where I see x, I need to put a there. So I'm going to get what? 2a plus 1. Yes, this is what we're going to solve. This is what we are going to solve. We are going to find f of a. Now, so f of a must be defined. That is one condition you're supposed to know. Now, 2, it means you're supposed to get the exact value of f of x. And don't forget that whenever we have a polynomial functions, f of a is defined for all polynomial functions. I'm going to talk about it. And then f of a is also defined for all trigonometry functions. Yes. Now, let's see. Now, 2. Then the limit of f of x where x is approaching the a must exist. Now, the limit of f of x where x approaching the a, that particular value a must what? Exist. Now, we've talked about limit. If you know you don't know limits, make sure that you go and check the videos on limit. Then you read something small about limit. I made a lot of introduction on the limit. It is very, very important. Make sure you go and check that one before you come and watch this particular video. Go and check introduction for limit. I talked about the two-sided limit and then one-sided limit. Yes, don't forget. Now, when we say the limit of f of x where x approaching a must exist, now, when we talk about that, then we are saying that the limit approaching a from the left is supposed to be the same as the limit approaching a from the right. Please go and watch the introduction to limit. Yes, it will help you. Go and watch it. Go to my playlist, go and watch introduction to limit. It's going to help you. Now, this one means that when we say this one exists, it means that is limit of f of x where the x is approaching a from the left should be the same as limit of f of x where x is approaching a from the right. Now, if we were able to confirm that limit as x is approaching a from the left is the same as limit f of x where x is approaching a from the right. If we're able to show that they are the same, then we will say that the f of x what exists. It exists. Now, the last one is C. Now, if lim of f of x, that is this one. Now, don't forget this one is limit f of x. This and this, it's giving you one-sided limit. You get it? This one is one-sided limit. This one's another sided limit. This one is both-sided limit. Now, if f of x approaching a is the same as f of a. Now, so we have these three conditions. The first condition is that the f of a must be defined to f of x where x is approaching a must exist. Then we explain that before this one before we can consider this one as exist, it means that the limit is supposed to satisfy the left hand side and the right hand side of the limit. Now we are always going to apply this one when we are talking about piecewise functions. Because the moment the thing is a piecewise function, that's when we can be able to identify when it's approaching from the left and when it's approaching from the right. Get it? So we're going to use most of this one when it is piecewise function. But when it's a normal polynomial functions and then rational functions, we are just going to use this one and this one to confirm our answer. Yes. Now, limit of f of x where x is approaching, you don't forget that you know how to solve for limit of f of x. Yes. That one we are not coming to identify whether it exists. I'm going to find limit of x, and then when x is approaching a, mostly limit of f of x should be the same. You get it? It should be the same as f of a. Now, so when f of a and the limit of f of x where x is approaching a are the same, then when all these conditions are met, then we're going to say that that particular function is what? Continuous. Now, whenever any of these conditions is not true, if one of this one is not true, then the particular limit or the function is not continuous. The function is discontinuous at the same value. S is equal to what? A. Don't forget that when we have a curve, you can predict so many values of x to get the corresponding values of y. So at any point in x, we can check whether it is continuous or discontinuous at that particular what? Value. So follow me closely. Now I'm going to explain something small here. Now, aside this one, whenever I have a polynomial function, linear function, I'm talking about linear function, quadratic function, and then cubic function. Yes, they are all polynomial function. This one will always be defined. That is one. Two, this one, the limit of x where x is approaching a specific value will always be the same as f of a. Anytime you have a linear function, now keep this very well in the mind. Linear function, quadratic function, polynomial function. You get it? Yes. Because if I have f of x is equal to 2x plus 1, and then I'm looking for continuity at x is equal to 1, it means that I'm going to have f of 1, that is f of a. F of 1 will give me what? Okay, no, I don't have to even do it like that. Now let me see. Let me find f of a. Now, let's say x is approaching a. Now, f of a, we are going to get 2a plus what? 1. That is for the first condition. Now, for the last condition, I'm looking for a limit of what? F of x, where x is approaching a. And whenever x is approaching a, it means that I'm going to have limit of x approaching a. Now, what is f of s? F of s is 2x plus 1. The f of s here is now 2x plus 1. Now, how do we find this particular limit? I've told you that go and learn my limit. Go to my playlist, go and check limitation of a function before you come here. Now, when x is approaching a, where we see, then when s approaches, it means s is approximately equal to a. So I'm going to get 2a plus 1. What are you getting here? This one is f of a, and this one is the limit of what? F of s, where s approaching a. We are getting the same answer. Yes, we are getting the same answer. 2a plus 1. This one's also 2a plus 1. That is why we are saying that, yes, when you have any polynomial function, the f of a is always the same as limit of f of x, where x is approaching the same a. Yes. Now, let me guide you through one particular thing. Now, follow me closely. Now, note this one. Polynomial functions. Polynomial functions. Now, it means I've combined all of them. And trigonometry. Functions are always continuous. Now, polynomial function and then trigonometry function, they are always continuous. No matter the situation, it will still be continuous. Yes. Now, and then two, the only time you can identify, okay, let me add this one. Piecewise function. Piecewise functions are sometimes continuous. Now, when we have a piecewise, I'll talk about a piecewise function. Now, when we have a piecewise function, it can be continuous, it can be discontinuous, yes. So that's the difficult aspect. Most of the time when you have a piecewise functions, yes. So anytime they ask you to find the continuity or discontinuity of a piecewise function, you need to do a lot. You need to test all the conditions for continuity to check whether they are still the same. You understand? Yes. So I'm going to explain piecewise function. Yes, so follow me closely. I want to make this thing very, very simple for you. This one is both for university students and then SHS students. Yes, all over Africa. Now, two, rational functions. Rational functions. Rational what? Functions. Are mostly rational functions are mostly discontinuous. Now, rational function is a function f of s where s is equal to what? It can be expressed as this one over what? H of x. You get it? Now, when you have a rational function like this, and then anytime the f of s is equal to 0, that is only fine. We are going to get a discontinuity here. Yes, anytime the denominator will be equal to 0, we are going to get a discontinuity there. So when you have a rational function, they ask you to find where the thing is discontinuous. Take the denominator and equal it to 0. Yes, find where it will make the thing undefined. Don't forget, the moment it's undefined, it means we can't define. So therefore, it is discontinuous at that particular what point. So when you have a rational functions, it is not always discontinuous, but mostly discontinuous. It is discontinuous when we equate the denominator to be what? Equal to 0. So whenever the denominator is equal to 0, then that particular thing becomes what? Discontinuous. But when the denominator is not equal to 0, then it is going to be continuous. You get it? Follow me closely. Yes. Now, if this one is discontinuous, then it can be removable, or it can be a whole. Now, what I'm saying is that if this one is continuous, it can be a whole. Remember, I mentioned a whole when I was talking about a curve. Yes, pothole on a road, it becomes a whole. It can be a whole or removable discontinuity. It can be a whole or removable or jump, as in jump what? Discontinuity. Discontinuity. You see how the thing is? I will explain the whole, I'm going to explain the whole discontinuity and then the jump discontinuity. You get it? Yes. Now, so keep this on me. So we are going to test all of them. Don't worry. Now, let's look at this. Now, let's say we have on a Cartesian plane. Now, let's consider a Cartesian plane like this, where we have a curve, and that particular curve, a function in the form of a curve. So let's say we have a curve like this. Now let's consider this particular curve. Now let's say at here x is equal to a, and at this particular point x is equal to what? B. Now let me explain this in very well for you to see, understand. Now from here, you're having a smooth curve. So it means that the function f of x, the curve f of x, is continuous from here. Now after here, you see the curve is not smooth. You get it? There are some breakages here. Now this breakage is called a hole. You get it? It's called a hole. Now how are we going to identify this one on a function? Now how are we going to identify this one on a function? Now when we have a function x plus 1, x plus 2 divided by x plus 1, what are we going to have? Now this one will cancel this one. Now this is what we call a removable factor. So since we have x plus 1 cancelling x plus 1, we are going to get a removable factor. And that removable factor will create a hole in the curve. And that particular hole is what we call the removable discontinuity. Removable discontinuity. So we're going to create a hole here. So at x is equal to a, the curve is discontinuous because here the curve is not moving straight. So this is a hole or removable discontinuity at x is equal to a. Now at this particular point, the curve was moving like this. Now when it gets to this point, it didn't continue, it didn't create a hole, but it moved from here to here. You get it? Now this one is what you call jump discontinuity. This is what you call jump discontinuity. So from here, it's moved from here to here. Let's say you are crossing a road and there is a gutter here. What are you going to do? You need to jump. Then you come and continue. That one is what you call a jump what? Discontinuity. Meaning at that particular point, the curve cannot move smoothly. It's called a jump what? Discontinuity. So when they give you a curve like this and they ask you to explain, you need to know where it is continuous and where it is not continuous. If it is not continuous, what type of discontinuity? It can be a removable discontinuity or a hole. And then what? A jump discontinuity. I hope you get me. I hope you get me. Yes. Now we are going to solve a lot of questions on this. I want to end here. Then in the next video, I'm going to explain more. I don't want the video to be too long. You get it? Yes. I want to explain more. I'll talk about rational functions. The polynomial functions are all continuous, so I'll not talk about it. Yes, I'll talk about the rational functions, and then yeah, I'll talk about rational function and I'll talk about piecewise function. I'm going to focus more on that rational function and piecewise what function, because rational functions can be either continuous or discontinuous. It depends. And then the piecewise function can also be continuous or discontinuous. That one too depends. Yes, so that is why I'm going to focus more on that. See you in the next video. Bye bye.